fellow algebra students, once again. Okay, so now we're looking at this problem here. I'm going, oh, God, how am I going to do this one? Now, I remember from yesterday, I think the exit ticket from yesterday, I believe it was the exit ticket, it said that we had to simplify something that looked like this, right? 1 over the square root of 11, I know I can't have a radical in the denominator in the bottom number. So the way we solved that problem was just multiplying it by 1, but my special version of 1, where square root of 11 times square root of 11 just becomes 11. And 1 times the square root of 11 becomes square root of 11. So our final answer is kind of funny looking. Square root of 11 but that's correct. That's fine. You can't do anything. You leave it like that. That's good. Now the problem is I have 2 square roots under here. I have square root of 10 and a square root of 5, and they're added together. I can't do one without the other. So we're going to do something what is called a conjugate. Now, a conjugate with this type of problem has a special way of thinking it. So this problem, what I want to attack here is the square root of 10 plus the square root of 5. I want to get the conjugate. So, well, let's do another example. The book gives square root of 7 plus the square root of 3. And they say, well, if you multiply this number by square root of 7 minus the square root of 3, that's the conjugate. Now, on the slides, you'll see there's the definition of conjugate. It says on the sum and difference of the same 2 terms. Okay, so I'm just going to do a little bit of box method here. And we'll see how this thing works. It's almost like it's magic. It's really interesting. So square root of 7, square root of 3, square root of 7, square root of negative 3. I'm saying, okay, friends, now how does this work? Well, square root of 7 times square root of 7, remember, is just 7. Square root of 7 times the square root of 3 is square root of 21. Square root of 7 times negative square root of 3 is negative square root of 21. And square root of negative 3 and square root of 3 is just negative 3. So wait a second. So let's pull these out. So I got 7. I got square root of 21. I have minus the square root of 21. And I have minus 3. Square root of 21 minus the square root of 21 is nothing, 0. So I have 7 plus minus 3. 7 plus minus 3 is just 4. Would you look at that? Got rid of the entire radicals. This whole thing, it became 4. It's not even longer a radical. It's just 4. So, for this one, okay, so let's do this one in another color. Let's box this one off. We'll save that later. We'll figure out how to do the conjugate here. I'm going to do this one in green. I'm in green mood. Okay? So I do square root of 10 plus square root of 5. Again, same number, but instead of square root of 10 plus 5, I do minus. Now this works also if this was a negative. You can make a positive one there. All you're doing is changing the signs. Do a box method. You could do the distributive property if that's what you like to do. I like to do the box method because I think it's easy to see what I'm doing. Okay, square root of 10 times square root of 10 is just 10. Square root of negative 5 and square root of positive 5 is just minus 5. Now I'm just going to do this. Square root of 10 times square root of negative 5 gives me negative square root of 50. Square root of negative of 10 and square root of a positive 5 is just positive 50. Pull those numbers out. I get 10 square root of 50 minus plus 10 plus square root of 50 minus square root of 50 minus 5. Those cancel out. Square root of 50 minus square root of 50 is nothing. Down 10 minus 5. 10 minus 5 is 5. Look at that. 5. Now, what happens next is I put it back, this number 5, all the way back here. Now, to get this, I have to multiply. Like we did here, we multiplied the top and the bottom by square root of 11. I have to multiply both the top and the bottom by our conjugate, which was square root of 10 minus square root of 5. Now we know we just solved what this happens. This becomes 5. So the number on the bottom, that's it. Now the number on top, what I'm going to do here is I'm going to do the distributive property. This is a good spot to use the distributive property. Negative 3 times the square root of 10 is negative 3 square root of 10. Negative 3 times negative square root of 5 becomes positive 3 square root of 5. Can't make anything any easier, so we just leave it be. And that is the end, folks. That is it. It's negative 3 square root of 10 plus 3 square root of 5. Remember the steps. You find the conjugate, 1. 2, you do something like the box method or distributive property, and you get the answer. Now, yeah, it's going to be relatively simple. There's another formula. They say this, shortcut. If you're good at remembering, they say, let's use the one I used in purple, that example, right? This one where it says conjugate, this example. There's a short formula for that. And if you remember this, that's great. If not, that's okay. You just got to remember what the conjugate is. They say if you have something like square root of 7 plus the square root of 3 times the square root of 7 minus the square root of 3, the conjugates, that's equal to the square root of 7 squared minus the square root of 3 squared. Now, square root of 7 squared is just 7. Square root of square root of 3 squared is just 3. If you can remember this rule, you think how much time that saves you, right? We wouldn't have to do all this. But I always show you the long way because that always will work. If you remember the short way, you probably could do a little bit faster. So you could just go in here, get that, and then when you plug it back into your problem, you have half the problem done. You just have to do the top half. Interesting idea. All right, guys, I will talk to you later. Good job.